Dear friends, welcome to this electrical engineering knowledge sharing channel. Today we are going to discuss about the changeover scheme for the control power and auxiliary power to 11 kV switchgear. We have already discussed about the auxiliary power and the control DC control power cabling arrangement and cable block diagram, and we have illustrated in details what are the various loads which need to be fed by this DC control supply as well as AC auxiliary control supply. And we have seen that in both control supply and auxiliary power supply, always we take two power supply for the same purpose. Like when we have a 120 volt supply, we have a two independent 120 volt supply coming to the switchgear. For 48 volt or 24 volt DC control supply, similarly we have a two independent power supply coming to the switchgear. For the 240 volt AC auxiliary power supply, also there are two independent power supply coming to the switchgear. Then inside the switchgear, this is coming to a particular panel. Inside that panel, the necessary wiring or changeover process is made. Now, the intention of this changeover process is that in case of failure of any of the power supply should not be interrupted. So, the various AC auxiliary power devices or the 120 volt DC or 48 volt DC various control devices should get the power uninterrupted. So for that purpose, the intention is 120 volt power supply which are taking from two independent source coming to the switchgear will make such a relay logic or relay scheme, so that in case of failure of one of the independent power supply, other independent power supply will deliver its power to the dedicated panels or dedicated devices, as well as the devices which are connected to the failure power supply also to be catered by that live or the available power supply. That means in case of failure of one of the power supply, the other power supply will cater for the entire load. In case suppose 120 volt DC supply is catering to its switchgear, which has considered there are suppose 24 panels. So out of these 24 panels, 12 panels will be supplied by one source. Another 12 panels will be supplied by the second source. Suppose source A is a 12 panel supplying, 12 number panel supplied by the B source. So intention of this, suppose this is the 120 volt supply we are talking about DC supply. The intention is that in case of failure of this first supply, A source supply, then this B source supply which was catering for 12 number panels, that supply will also able to cater to this A panel 12 number, A source 12 numbers panel. That means all the 24 number panel will be supplied by the B source which is available in case of failure of A source. Similarly, in case of failure of B source, A source will cater for its own 12 number panels, as well as it will supply the failure power supply connected source panel, that is the rest 12 number panel also supplied by A. So that will be the changeover scheme has to be made in such a way so that in case of failure of one of the power supply, other power supply will cater for all the loads. Suppose we have considered here, first we are considering DC supply. Now here is one consideration, DC supply and AC auxiliary power supply, there is a slight different arrangement for the changeover scheme. In the case of DC supply, we can connect same voltage level DC supply directly without any synchronization. Synchronization is not required for the DC supply, you know that. But in case of AC, two independent AC supply, we cannot hook up these two independent AC supply directly without synchronization. So in that case, we have to make a changeover scheme in such a way that two independent source supplying to a particular group of panel, in case of failure of one of the source, then only other source will go to there. So direct hookup in case of AC supply is not possible, but in case of DC supply, we can directly hook up. Also, we can do the changeover in such a way that in case of failure of one, other will take over that. That we will discuss both the options. First, we are considering common option, which is applicable for both DC and AC. In that case, if one of the power supply fail, then the other power supply will cater for the power for the control power or auxiliary power for the entire source. So this is a source A and this is a source B we have considered. Source A we have tagged as a source A. This is our source A. This positive and negative. This is a DC supply you are considering. This is positive and negative. This is we are considering source A. Okay. Source A, and this is we are considering source B. This power supply we are considering source B. We have shown here DC-DB1. This is suppose 120 volt DC. Okay. It could be 48 volt DC. It could be 240 volt AC as well. In both cases, all the three cases, this scheme is applicable. Okay. In that case, what we will show? In case of failure of one of the power supply, other power supply will cater for its own load as well as other failures supply load. Suppose in normal condition, this source A is catering 12 numbers panel. We are considering in this way 12 numbers panel, or suppose this is catering A bus panel. Suppose there are two bus in the switchgear, A bus and B bus. A bus has a 12 numbers panel, B bus has a 12 numbers panel. So this A source is catering for A bus panel. We are considering in that way also A bus panel. And this is B source is catering to B bus panel. Okay. In that way we can also consider which has also 12 numbers panel. So this way we have divided. Okay. Normal condition, what is happening? This is the MCB, required rating MCB as per the power requirement. This is in switchgear A. This is in the switchgear, in the one of the panel of the switchgear, where these MCBs are located. Now this red color part is there inside the switchgear. So this power supply is coming from the DCDB, either DCDB or ACDB as per the requirement. In case of AC power supply, this will be the ACDB. In case of DC power requirement, it will be the DCDB of the respective voltage. So this is a DCDB1 and this is a DCDB2. These are two independent sources. There is no relation between these two at the top. So from that DCDB or ACDB, this power is entering. This is the entering point inside the switchgear. So entire portion is inside the switchgear panel. Suppose this is this entire system containing inside a switchgear a panel number. Suppose we are considering panel number 12. To panel number 12, this entire system is located. The entire wiring devices, everything is located. We consider in that way. In that case, what will happen? Panel number 12, it contains these two MCB. These are the power supply MCB, 2-pole MCB. Maybe it is a 50 ampere rating, 2 MCB inside the panel, which is receiving the power from the ACDB or DCDB. Then it is coming to the switchgear outlet terminal. From this terminal, there is you can consider this is a bus, this is a positive bus, and this is a negative bus. From the positive bus, all the 12 panels wiring is going. From here, the negative 12 panels wiring is going. We can consider in that way. So normal condition, what is that? These two power supply coming through the MCB, supply is healthy, it is going to this terminal. That is a normal condition. Now, in case suppose the B supply failed, this supply suddenly got failed due to some reason, maybe that MCB tripped, or maybe this DCDB or ACDB itself will lost its power. In that case, what will happen? There is no power supply over here. So what is happening here? We have put two new devices in this scheme. This device is actually under voltage relay. This is one under voltage relay for the A source. There is one under voltage relay B source. This under voltage relay, how it is working? It is working. This 27 relay is normally energized. Okay. When the voltage is more than 80%, suppose it is 120 volt, 80% means 96 volt. When the voltage across this relay is more than 96 volt, the relay is picked up, means relay is energized. That means when the supply is healthy, both the relay are energized and the relay is a healthy condition. So relay energized means this is we have a setting. If the voltage is more than 80% of the rated voltage, then the relay, this under voltage relay, both the under voltage relay will picked up. If the B source voltage is more than 80% means which is equal to 96 volt in case of 120 volt, then 27B relay will picked up. That is the normal condition. And that is this is the case. Now what is happening over here? Now we are considering B source has failed. The moment B source has failed, then what is happening? This 27B relay is getting under voltage. It is the voltage is 0 or that is less than 80%, immediately the relay will drop out. The relay drop out means and there is no power supply over here. So in that case, what do we need to do? We have to bring the power from A source to B here in this terminal. This terminal to be energized from the A source. So what is the arrangement for that? We are making one auxiliary scheme over here. we are making a relay scheme. This 27A relay and 27B relay auxiliary contact we are using. This how this system is working. This is a 27A relay NC contact. Normal condition NC contact means when the relay is not energized, this is NC, and this is when this relay 27B is not energized, this is NO. That is the condition. It is a de-energized condition of the relay. This contact position shown in the de-energized condition of the relay. Now 27B relay has dropped because 27B relay has failed. If the 27B relay is failed, then what is happening? This 27B relay, that means there is no power supply over here. If there is no power supply over this device, will not work out because this need auxiliary power from here, but that power is not there, so it will not work out anything. So let us come over here. What is happening over here? The moment B supply is failed, but the A supply is live, means this supply is live. So here what is happening? The 27B is dropped out. With voltage is less than 80%, means 27B relay is de-energized. The moment it is de-energized, you see what is happening. This is a 27B relay auxiliary contact. So when this relay is de-energized, immediately 27B relay is come to the NC position, right? It is a de-energized condition, and at that time the 27A relay is energized. 27A relay is energized means this become NC. This is also become NC because it is normally NO condition when de-energized. When the relay is energized, it is a NC. That means when the B supply is failed, 27B relay is under voltage, means de-energized condition. So this contact remain NC, and 27A relay is energized. The source is available. So this become NC. Immediately KMB relay will picked up. Okay, it is actually I am considering relay, but actually this is not the relay. This is a 4-pole contactor. Why we are using contactor? I am coming back to that. This is a 4-pole contactor. It could be DC contactor. This 4-pole DC contactor. This contactor KB, it has a 4 auxiliary contact. Suppose each rating is a 50 ampere rating. This contactor right there. So this is a 2NO 2NC. I am using first 2N. This 1B and 2B 2NO contact. This NO contact I am using to take the power supply from A source to B source. So this is one NO contact, and this is another NO contact I am using over here. This is the arrow showing power is going from here to here. So the moment this power supply failed, KMB is energized. KMB energized means this NC contact, NO contact become NC, and then the power is going from here to this, and then it is flowing from here. So what is happening? The moment B supply is failed, immediately power is going from this source to this way. Okay, so I am getting the power from A source to B source. So that is the way this changeover scheme working. Similarly, when the A source failed, what is happening at that time? This voltage is become less than 80%, right? So less than 80%, and this is remain energized. It is healthy. So at that time, 27BA relay is picked up, but 27A relay is dropped out. The moment it is dropped out, what is happening? Now we are considering our A source failed. This source is not available. This source got failed. The moment this source got failed, then what is happening? You see here, then this system will not work out because there is no power supply available. Now come to here, what is happening? Which is healthy. This source B is now healthy. So what is happening? This B healthy means this is supplying power, and this is remain energized, right? And it is supplying power its own B bus panel, 12 number panels. And at the same time, what is happening? At that time, as this relay dropped out, so this 27A, this contact come back to normal, that is a 27 remain NC, and 27B is energized, means this NO become NC. So these both are NC, control supply coming to this KMA contactor, and KMA, this is the negative side going back, so it is getting energized. The moment it is getting energized, you see here, now what do we need? As this is healthy, we need the power supply should come from here to here, because there is no power supply over here. The moment KMA is energized, you see here, we have used to KMA NO contact over here. The moment it is energized, this become NC, then the power will come from here, and then it is going to the rest 12 number panel. That means in either case, either this supply fail or this supply fail. At a one time, one supply fail, not both the supply. If both the supply fail, then it will not, because there is no power supply. What we can do? And that we do not consider in the design. In the design, we always consider only one supply fail at one time. So in case of either A supply fail or B supply fail, then the failure supply panels will be supplied power from the other healthy source. So this is the changeover scheme. Now consideration over here, why we are using KMB and KMA contactor, because you see, if we use a auxiliary relay like this under voltage relay, all the auxiliary relay, this contact rating is very less. It is a maximum 5 ampere rating, and that rating we cannot use in the power circuit. This is the power circuit actually, you see, this is the main power. This main control power is flowing, which may be 50 ampere or 25 or 30 ampere depending on the VA capacity of this 12 numbers panel. When it is supplying, it will be supplying all 12 numbers panel plus as well as this is supplying this. So we have to design the contact rating in such a way it can carry the total control power. So as this auxiliary relay contact is not adequate, that's why we are using a contactor which has a various rating available. Motor contactor, you can be up to 500, 600, 1000 ampere rating. So that's why you are using a contactor instead of contact. Only difference in case of DC, this will be DC contactor. That means the coil of the contactor will be DC, and in case of AC, it will be AC contactor. So this is the way it should be made. Now question is, one of the drawback over here in this scheme. Now when it is supplying power from here to here, suppose the A source, as we discussed in the last, A source fail and supplying power from the B source. In that case, B source power is coming over here and then it is flowing like this way, right? This is the B source flow. B source power flowing to the A source. This is the way it is supplying power. Okay, it is going like this way. But at the same time, you look into this also going in the backward. So in this backward, if suppose this power supply fail due to this main supply fail, not the MCB trip, MCB still remain energized, it is remain connected. So in that case, when the power supply coming from the B source to A source to supply this panel, it is not only supplying the panel, at the same time it is supplying power to the backward also. It is a backflow is there, you see, it is going backflow up to this panel. That means this panel is de-energized, but inside the panel this power is going back. That is not acceptable. So what we have to? We have to cut off this. So what we should do in that case? As we are using KMA contact, this 2 number NO contact over here, we can connect over here to NC contact of KA relay. Okay, this is the NC contact. These are 2 NC contact of the KMA relay. So what will happen over here? This is we are using 2 NO contact over NC contact. Okay, these are 2 NC contact of KMA relay. So what is happening? KMA relay. In that case, what is happening over here? The A source is failed. A source is failed. At that time, this B source power is going, and at that time KMA relay is energized. Energized means this NC contact, that NO contact become NC, and this NC contact become NO. This will be 3A and 4A contact. It become NO. The moment it become NO, that means the backflow will be stopped. The power cannot go this side. So that's why we are using 4-pole contactor. 2 NO contactor we are using to take the power, and 2 NC contact we are using to stop the flow of power. Now in the normal healthy condition, what is happening? Let's see. In the healthy condition, you see both KMA and KMB is de-energized. Why? In the normal healthy condition, both 27A and 27B is energized. The moment 27A is energized, for this what is happening? It become NO. Okay, and this become NC. But as it is NO, KMA will not get any power, control power will not come to the KMA relay, KMA contactor. So KMA will not energize. If the KMA is not energized, that means this remain NC. So power is going, backflow is, the normal power is flowing, there is no issue. And this is open, so there is no connection between this. And in this case, what is happening? Here also, in this case also, you see, this is the normal, it is healthy condition. In this healthy condition, 27B is energized, means this become NO. This contact become NO and this become NC. Okay. So this is connected, but as it is NO, power is not going to KMB. So KMB is not energized. So this is remain open, and this KMB contact will be coming over here in the same way as KMA. This will be KMB contact, NC contact. This NC contact remain connected. So power will be flowing, but the moment this power supply fail, this power supply KMB, the moment KMA power supply fail, when this power supply fail, power will come from KMB to over here by this path, and at the same time this KMB NC contact, this is a KMB contact, okay? KMB NC contact will stop the backflow, because the moment KMB energized, this NC contact become NO. So in case of failure of this power supply, this contact become NO, and this contact become NC, so it will give the power and it will stop the backflow. So this way, this KMA relay 4 contact, 2 contact will be using to take the power from this source to this source, and same time another 2 NC contact will stop the backflow. So 2 contact to be used over here, 2 contact to be used on the failure circuit to stop the backflow. So this will be the changeover scheme. In case of one supply fail, the other supply will take over. Here maybe one of the things will happen, because after the failure, all the relay, all this contactor to be energized, then only the changeover will take place. It may take some few millisecond. So that delay will be there. Okay. But if it is a critical like that, anything we cannot some millisecond, 1 cycle stop is not possible. In that case, in the case of DC, we can do alternative arrangement, but in the case of AC, we cannot do this type of arrangement. We have to go through the synchronization of these two supply, which we have discussed in the case of power supply, main power supply. But at the auxiliary power supply, a small amount, so this type of synchronization is not very practical and not economical. That's why in this case, we do not consider in that way. And AC power, as we have already discussed in the case of switchgear, AC power we are using for all the auxiliary power like a spacer, lamp inside the panel, indication lamps, then your tube light, plug socket, all you can wait for 10 minutes. That is no use. No use issue of that. So in that case, this changeover scheme will absolutely fine for the AC supply. And in case of DC supply, if we feel that this power supply failure is not acceptable, this power supply not failure, this power supply changeover time some millisecond is not acceptable, we need a continuous power supply without any interruption. In that case, we can make alternative arrangement. And second point, sometimes if we do not have a contactor of 4-pole, in case of DC supply, not for this, in case of DC supply, we can make another arrangement. Instead of NC contact, we can use a diode over here. Okay, we can use a diode, one forward bias diode over here, one reverse bias diode over here. So that will, what will help that will, in normal condition, power will flow, but when this power is coming from here to here, then this become positive and this become negative. So it will be a reverse bias and this also reverse bias. So this power will not go. That way also we can do instead of NC contact. Okay. So this is the arrangement. Now if we think that in case of DC, we cannot stand, we cannot wait for a moment, in that case we can make alternative arrangement in which it will be very easy to get this power supply. In that case, what will happen? We don't need all this relay scheme and all these things. Okay, in that case, what we will do? We will make a very simple arrangement. In case of DC, it is only possible. In case of AC, you cannot make this because the diode will not work in this way. What will happen in this case? How we will do that? You see here, this is I am delete it. This and redraw it again. Okay. So this is our MCB. This is our MCB. 2 MCB over here. Similar, this is MCB and power supply is coming over here. What we can do? Suppose we can connect over here. This inside the switch gear. This is, we can connect in this way. Suppose this is a positive and this is negative for source 1. This is source 1. Okay. And here we can do one thing. Here is it is a source 2. Source 2, it is a positive and this is negative. Both 120 volt or 120 volt or 48 volt. Both should be same voltage. Okay. In that case, this positive and this positive we can connect. And this negative terminal and this negative terminal we can connect. And this positive will go to a bus and this negative will go to a bus. And from the bus, all the 24 panels will be supplied. Okay. What we will do in that case? In that case, what if in case of failure of the other will be there, but at this time backfeed also there. So we will put 2 diode over here in reverse direction. This is the forward, this is reverse bias. So normal condition, what will happen? If the diode is not there, normal condition, no problem. It will go power in both case, and in case of failure of one, other will supply the power. But in case of failure of one, what will happen? This power not only feed this also go to the backfeed. To stop the backfeed, we put the diode over here. If we make this type of arrangement, then it will be very simple arrangement. Without any relay scheme, we can get the changeover. You see this way. So normal condition, when this is positive and this is negative, these are about forward bias, the current is flowing and going back. Here also the same thing, but the moment this power supply fail, so this is the under voltage, there is no voltage over here. So in that case, this will supply the power, it will come to the bus, and then when it will try to give backflow positive, it will be reverse bias, so power will not flow this way. So this way, by this blocking diode, we can blocking or even putting the diode in this way. The diode rating should be suitable for the total power rating. We can use in case of DC supply. AC supply not possible because we cannot directly hook up in the AC supply due to frequency and power angle difference for the single phase supply. So this is the way we can make the changeover scheme for the DC control power and AC auxiliary power. So with that, we are completing the schematics. Now we'll discuss about the single line diagram and the 3-line diagram in the next video, and with that we'll be completing the switchgear control schematics. Okay, and I have already discussed about this. In addition to this, another point I want to highlight, that if you look into the switchgear drawing, we have discussed about the switchgear various control schematics and the power changeover scheme, everything. But when you receive a drawing from the vendor, for the switchgear vendor generally for the medium voltage and high voltage switchgear, they give for each panel separate drawing. They don't give one complete drawing, that is huge. So because each panel has a separate drawing, his wiring is different, field wiring is different, that's why each panel has a separate drawing. So if you look into a particular panel, suppose a generator panel or a transformer panel, if you look into any of the panel, you can see the various drawing with this drawing package for a particular panel supplying by the vendor, consisting of the various drawings. Mainly, what are those drawings? Most of the drawing we have discussed. Now I am giving a detail of those drawings. Generally, any vendor, any switchgear vendor, medium voltage or high voltage switchgear vendor, when he is submitting the vendor drawing for approval, they generally give the drawing first. They give your index sheet where they will mention all the drawings they are submitting with this. Number one. Then they will give one legend and symbol. This may be common, one drawing for all the panels, legend and symbol. That is the second drawing. Third drawing, they will give one layout drawing. How the panel layout. Suppose this is the panel. We have already, if we consider 2-tier panel, so top tier will be control, bottom tier will be power section, where the circuit breaker, disconnector, CT, PT, all this thing is located. And on the control section door, all the relay, then all the meters, all the monitoring devices is mounted over here. So the complete layout, they give one layout drawing with the dimension, length, breadth, height, all the dimensions they show over there. That is called the layout drawing. The layout drawing also they provide with the each panel layout drawing, they provide separately layout. They give one layout drawing. Then from the layout, they can find out what are the various materials inside that particular panel. So they give a material list. This material list means they will give the description of these material, technical specification of the material, country of origin of those materials, of those devices. Suppose a circuit breaker, they'll give the circuit breaker name, then model number, technical rating, short circuit rating, then how many contacts available. Most of the things they mention over there. Country of origin, they will mention also, and quantity also they will mention. Okay, that is a material list. In this way, all the material they will tabulate and they will give the material list. And tentatively possible, they mention on the location. It is located inside the panel or on the door, where it is located, that also can be mentioned in the material list so that easily identified. Then they will give one single line diagram for that panel. Single line diagram or relay metering diagram, you can say single line diagram. Then they will give 3-line diagram. Okay, 3-line diagram. After that, what they will give? They will give a control schematics. In that control schematics, it consisting of closing scheme, tripping scheme, interlock scheme. If there is a synchronization, there is synchronization scheme. Then auxiliary relay scheme, annunciator scheme. Then various protection relays, input output scheme, protection relays, various components details. Then circuit breaker, we have already discussed. There are various contacts in the circuit breaker. That contact detail also they give it. Then they will give the overall field wiring facilities. What are the for the field wiring? What are the various contacts or various terminals they are providing? That also they will provide. How is it? Normally, when you are finally switchgear schematic is completed, then we have seen the switchgear is connected to the various outside field devices with the various control equipment. So there will be field terminal block, field control terminal block. We call this field control terminal block. In this terminal block, all the auxiliary contact or all signals. Suppose there is a breaker NO contact. This is a breaker NC contact is connected over here. Suppose here is a 95 relay. 95 relay contact is connected over here. Suppose here is lockout relay contact connected over here. So here it will be, suppose 52A, 52B, it is 95, it is A, suppose 86. So it will be written over here. Suppose it is going to DCS, to DCS. What is purpose? It is a CB1. So this is a 52B NC contact with CB off. Suppose it is going to PMS. Okay. Suppose 95 it is going to control panel. Write down control panel. It is a, what is the purpose? Tip circuit healthy or tip circuit fail. Like that. So all this thing will be written over here. So when you are doing the cabling work, you can immediately find out from where, suppose this terminal number 1, 2, 3, 4, like this terminal numbers is there. So I know FCB1, terminal number 1, 2, for CB1 it is going to DCS. So when I DCS breaker 1 status record, I will take from here. So this way they will make one terminal, one drawing where all the field terminals, where the various signals are taken or signal coming from the field or are terminated in this. Okay, that will be the another drawing will be there, and this will be more or less, these are the various drawings the vendor will submit. And in addition to this, if it is a various relay logic is there, they can make the various relay logic gates, and that also they can submit with the drawing with this package. And then they will also make a schematics. What are the various signal which is tripping the breaker? What are the various metering parameter you are taking to higher? All these things they make on matrix form. In that matrix form, they can demonstrate all these signals. So this way, each panel drawing is made, and that will be submitted for your review or acceptance or approval. This way, switchgear vendors generally submit the drawings. Okay, this is a brief of that. So let's please go through this. And if all my videos, if any way in the real way and tangible difference if you find in my various videos, and if it helps you, that would be my pleasure. Please go through this and share with your friends and colleagues, and so that it could be circulated more. And I hope that circulation will help you and your all friends and colleagues. Even a real and tangible difference is there, then it will be my pleasure, and I will be delightful for that. Thank you very much indeed. Thank you.